perspective, but as a physicist, do you really believe that there's classical data and quantum data? I mean, these are distinct things. As a physicist, you don't.
You think they are the same?
Well, do you not? You don't believe the classical world is somehow a limiting case of quantum theory?
I don't even make a statement about that.
No, but I just ask. I understand. I realise that from your formalism. That's fine. But I'm just asking you now, as a physicist, what do you really believe?
I'm not sure there. I can't make say yes/no answer to that. It's really about the ontological status of classical data. You're asking me, I guess. It's something to think about. There is no yes/no answer or any simple answer, I would say there. I think that this is a mathematical derivation and gives you sort of a framework to reason about that and put the question clearly.
Yeah, I understand that.
It doesn't require an answer to
sure.
that.
No, I understand.
I'm just implementing the capabilities that your measurement outcome can be copied, if you wish to. And to write down von Neumann projection postulate, I need this. I actually need this to just write it down.
Yeah.
So I'm just being very explicit in whatever I write down.
Yeah, no, I understand.
And from there I get a lot of stuff. Like, it's quite amazing that you get measurements, like the exact definition of quantum measurement spectra out of this. In the Hilbert space case, by something which seems to be a very innocent development conceptually. So.
I think what I learned at least that copying is not that very trivial, huh?
Copying is not and like the thing is, people in logic have been discovering that before. That it's like I just should put down the names. Actually, somebody who was doing this implicitly was Lambeck. He understood all that stuff about copying and deleting. He started to do that stuff in the 50s. So because he was like, what he was interested in the 50s was language, natural language. And like, nobody tells you that, but copying not is not the same as not itself. So it's as simple as that. So you only see source sensitivity in your language. You can just repeating a word is not the same as saying it once.
In South Africa it is.
Yes,
Why do you say that? In South Africa you use double negation for them.
So,
you do.
Yeah, so Lambeck in the 50s was doing language stuff, and then he saw that in general proof theory, where people were doing Cartesian closed category, that you didn't at all needed Cartesian structure to do everything. And I think things in a sense, proof theoretically became simpler. Gensen made explicit in his proof rules that you needed these structural rules of copying and deleting if you want to have a nice proof system. And then linear logic, a la Girard, the logic a la Girard, which was already implicit in Girard, which was already implicit in Lambeck stuff, but he then took Gensen's system and said drop the structural rules. What is the logic we get? And the logic is much nicer. And then this sort of stuff is even a more degenerate case where you identify conjunction and disjunction. But it's a super logic, it's like a hyper logic, while quantum logic used to be non-logic. So you get this, like this is the only example we did so far. We looked at Mark's theorem, it took like 3 minutes, like okay, we can prove this, blah blah blah. What about the classical stuff? This took another week to get this nicely worked out, like to get the copying and the deleting and stuff nice.
Well, what about diagonalization of operators, which plays a big role traditionally? I mean, is this something?
There is an abstract analog to diagonalization.
But does it need classical? I mean, does it need just...
Like, you know what this little bit does here? You see this little picture? Because I can't explain this completely, because this actually lives in the world of mixed state. We can define mixed state, we can define stuff like completely positive operators. And this little picture here, it eliminates non-diagonal elements with respect to its choice of classical object. Like you choose a classical context, which is one of these classical objects in which you can copy and delete. And like this little picture actually shows killing of non-diagonal elements, which happens in measurement. You lose the phases. So that's this little part here of the picture. So these things live there.